Okay, hello everybody, and thank you very much indeed for joining us for this case study session brought to you by VORTEX IoT. I'm Luke, the editor of Intelligent Transport, and I will be your moderator for the next 30 minutes. I think this promises to be a really insightful session as we hear from Adrian Sutton, founder and CEO at VORTEX, Behzad Haravi, founder and CTO at VORTEX, and also Martin Hancock, development director at National Express Bus. For the audience watching at home, please make sure to get your questions in during the presentation so that we can get them answered towards the end. But for now, Adrian, I believe you are kicking things off. So over to you.
Thank you, Luke, and good afternoon, everybody. Always nice to be on just the other side of lunch, so everyone is fed and watered and good to go, and we're not going to suffer from any sort of mid-afternoon or late afternoon dip. So we've hopefully got something exciting for you, something thought-provoking about what new normals are gripping our urban and mobility landscapes, and our view on that, and at VORTEX IoT, we pride ourselves on bringing innovative technologies to the market and working with some industry-leading players. So Behzad and I, founders of VORTEX, are very pleased to have Martin from National Express with us today, who's working with us on a very exciting project in the West Midlands 5G testbed. And we'll talk a little bit about that and hear from Martin and his views on that innovation and what it means to National Express as well. But let's go back to perhaps the title and really set the tone for the presentation, which is as an IoT business, we are seeing sort of quite exciting times lying ahead of us. But we focus on sort of a trio of technologies which we think the convergence of those is got transformative and paradigm shifting potential. Okay, and they're also driven, and the paradigm shift on each of these technologies is actually driven by this smart city, future mobility, connected autonomous cars market, and Behzad will tell us a little bit about that, what that means from the more theory perspective, and how the LiDAR is really sort of ripping up the rule book a little bit here. But LiDAR, 5G and AI combined and converging to transform the future of mobility is something that we have got huge interest in at VORTEX. And I hope you enjoy this presentation. So, Behzad, do you want to roll on and set the tone? Yes. And take it from set the tone into the message.
Thank you, Adrian, for the introduction. I would like to start with a question, really. How could the future of mobility landscape look like? And based on our prior knowledge of what's in the horizon in terms of trends, technologies, and expectations, we should know what features or characteristics it's coming in the future transport and mobility sector, and what's waiting for us. Firstly, we expect mobility to become more intelligent, and advances in AI, machine learning, and their growing integration in our day-to-day life has made us really accept that. We also expect mobility to become more and more connected, not just people and vehicles, which mostly they are already connected, but also the infrastructure and mobility assets, road assets, traffic assets, they all get connected, and advances in IoT, Internet of Things technologies, has enabled that. As a result of these two, I'm putting them into a cascade kind of a diagram, where as a result of these two main features, we will have new features like autonomous and driverless vehicles, collaborative mobility. We already use collaborative filters for navigations. We use new collaborative mobility aspects, including real-time vehicle-to-vehicle collaborations. We also expect the transform sector become more shared. We already have this with bike share, lift share, car clubs, and mode share. Adaptiveness, infrastructure and roads can become more adaptive to our ongoing needs and our needs at the time, and become more accessible. New ideas like flexible cabs and flexible areas for cabs and parking bays are one of our examples. And again, in the cascade, as a result of these four, I would say we'll have more sustainable, or we can expect more sustainable mobility to be able to cope with increase in demand and more resilient to societal and environmental changes. We wanted to also um, become more human-centered, be more adaptive to our needs, and become more personalized, even though it's shared. We expect them also to become more efficient, faster, cheaper, and cleaner, more green, decarbonized, and with ultra low pollution and safer. To achieve such landscape, I'll pass back to you, Adrian, to talk about maybe data and the role of data in this landscape.
Yeah, thank you, Bazad. You know, good segue, data, and we all know that 80% of the world's data has been created in the last 2 years, and that seems to be getting a bigger in context. Data is the new oil. It's full of cliches, all right? But as an IoT business, from the off, we knew that we would have end sensing devices or have an end-to-end system that actually became part of much broader infrastructure. But whilst IoT, and so there's some cool technologies, and we're talking about 3 technologies in particular that are transformative, the actual value in everything that we do is in the data. And that value is driving new urban business models, it's driving new ways of thinking, it's driving new normals, and it's driving new customer experiences across our urban landscapes and the way in which we travel and in which we expect mobility to answer those. Huge shifts in population to our urban areas, and it doesn't look as if the global pandemic will alter that. How we actually then take up the service, the pandemic will certainly have short to medium term implications on that. Okay, but you look at some of the numbers: 1 trillion. The mass segment will be worth over 1 trillion. Autonomous, connected, and on demand. These are messages which repeat time and time again. But one that really strikes me, and as we're going to come to talk on about things like 5G testbed and some of the work we do elsewhere, is by year end 2022, Gartner predicting that half of city open data portals will have failed to become ecosystem data exchanges due to lack of automated management. Okay, so it comes on to AI, the role of AI and the reach of LiDAR and the connectivity that 5G and other wireless mesh technology offers us. These are the things which avert those car crashes, for want of a better term. Okay, by year end 2024, these are on the horizon. At least 50% of smart city initiatives will include smart management of the circular economy. Cities will need to develop economic development strategies that will have Industry 4.0, healthcare, or tourism at their core. And we're seeing that, across some of the the big smart city programs in London, West Midlands, Manchester, and the like. Okay, but the key aspect here of everything is the ecosystem. No one provider has the answer. There is a multitude of providers, but they all must contribute to a much bigger picture, which is where Bazad's pyramid really begins to help define what that bigger picture needs to deliver upon. Bazad, back to you, perhaps.
Yeah, and following that, the key technology innovations. It's not limited to these 3, but we chose this because we work on them. Their cameras also important. LiDAR, artificial intelligence, and 5G. 3 disruptive trends and transformative technologies, as Adrian mentioned. LiDAR for accurate 3D mapping and digitization. AI and data fusion for processing, classification, and finally 5G for to create the connection between the two and creating reliable communication, high throughput and low latency and real time between these. so it can feed data to this future landscape, and also be fed and get data back from it. If I go through one by one, just to introduce, there's LiDAR, light detection and ranging. It can remotely create 3D representation of a scene or of an object by illuminating them through near-infrared laser. It creates a point cloud. The 3D version of it creates a point cloud of objects and the whole scene. It has come a long way, but in a short time, from 2005 until now, from use of LiDAR only for laser ranging, and then to spinning LiDAR. The different ways has been tried to steer the laser and create the 3D representation. The first way was for using spinning LiDAR. Difficulty was it was expensive, large, and not suitable for some applications because of vibrations, and it wasn't solid state at all. And now we have MEMS mirror LiDAR, which are smaller, lower cost, but higher market value, and they can create they become more solid state, not still 100%. There's still small, very tiny vibrations in the mirror arrays. And in future, in 2 or 3 years, we'll have silicon photonics LiDAR and available using optical phased arrays, and it will make the LiDAR units as small as what you see in the picture, that even can be integrated into our mobile phones very soon. It can be used to project USB as a projector, or it can be used to scan objects around us. And in maybe even more into the future, we can have quantum LiDAR using photon entanglement features of quantum mechanics to detect and trace even one photon that can be traced back from an object from which we will be able to see through the very dense fog. In terms of LiDAR types, it started with time of flight LiDAR using pulse of laser that it's sent to the objects, and return time of flight is calculated. It was and it is sensitive to ambient light and crosstalk a bit. Now we have coherent LiDAR, where narrowband filters are used to block these incoherent signals, which makes it more impervious to sunlight, glare, and interference. And we can also quantify distance and velocity at the same time using Doppler effect. Artificial intelligence. Gartner has named artificial intelligence as hot and hyped at the moment. The percentage of enterprises that have deployed and are using AI has grown from 4% cross industry in 2018 to 14% in 2019, almost quadrupling of it. It indicates that AI is really delivering results now. And it can cover a diverse range of applications, from natural language processing to machine learning. In mobility and smart mobility, we can use computer vision to detect objects and classify them, detect pedestrians. Anomaly detection in rail, we can detect changes in infrastructure, slow changes, and degradation, like changes in the ballast or geo assets on the rail. Even detects accumulation of sand or snow on rail. Path prediction, we can use it for asset failure prediction for rail and road infrastructure. And in pattern recognition, where we can not just classify objects, but also try to understand their pattern of movement and their behavior on road and rail. And next, 5G, upcoming 5th generation of cell network technologies, which is coming in different frequency range to cover a wide range of applications, from sub-gigahertz frequency for dense building and dense number of users and large events in cities, to high frequency sub 6 gigahertz for smart city applications, and even to millimeter wave frequency band over 24 gigahertz, offering high throughput for both download and upload in line of sight, suitable for transport and infrastructure sector. And with new features like beam steering, massive MIMO, dynamic spectrum selection, which can enable real-time Internet of Things and real-time LiDAR connectivity for future mobility platforms. I will continue with a few of our case studies. Firstly, we have CEBS, which stands for Continuous Urban Scanning, using 5G-enabled LiDARs. The idea is to use buses and municipal vehicles, public transport that travel the same routes over and over again in a day. Maybe every 5 to 15 minutes, one bus passes a route. If the buses are equipped with mobile laser scanning, they can create a 3D representation of the environment and scan the road surface, scan the curbside, and create a 3D model. And by using AI, we can create a 3D inventory of urban assets, including street furniture, traffic assets, and road surface condition. It works on this cross-section of LiDAR, 5G, and AI to provide us end-to-end solution for continuous urban scanning. LiDAR units on buses connected directly to 5G can create a point cloud as they move, and they're also equipped with GNSS, so they know where they have collected and from which direction. And they do baseline scanning, and we can then align these point clouds through space and time, temporally and spatially together to create that dense point cloud that we require for identifying these objects and point clouds of them, and classify them, and can remotely monitor their condition over time, where we have here a traffic post. We can track and monitor their condition, their physical condition. The sensors inside them also can track their internal states, and we can see their condition history and how they may degrade over time. The same is for defects on road, like potholes or curbside defects, or also passenger behavior or road marks. Different applications there. We have Martin here, so I think it's a good time to pass it to Martin to talk about this also from the bus operation.
Yeah, thanks very much. Martin Hancock from National Express. I'm sure there are lots of long-term uses of the data that we're going to get out of this type of equipment, but we've got a very specific short-term aim where we think this can be really valuable to us. Safety is our #1 concern in terms of operation. We've already got a lot of technology on the vehicle in terms of drive cam type CCTV, hazard awareness warning, and we've just started to specify CCTV mirrors on all our vehicles instead of external mirrors. But they all require some kind of human intervention. They're all reacting to events. We can download an event if something happens. If our vehicle runs into a tree, or a tree falls into the road, which is more likely, we're reacting to it. What we're looking for this type of technology is the predictive element. It's, as we said before, the sort of the pattern, being able to spot patterns, being able to spot movements in, we get movements in things like lampposts. They do gradually fall over. We equally patterns in pedestrian behavior, where we can actually see that pedestrians are congregating in a dangerous location. These will actually be very, very useful in terms of our hazard awareness. So we're looking at it, I'm sure, as I said, I'm sure the long-term benefits, long-term other uses of the data, but there's a very specific short-term benefit in safety, which we're hoping to trial in the West Midlands, and I'm sure it's going to produce some very useful results for us. Hand back.
Thanks, Martin. Yeah, and I guess the key takeaway from you is, you know, and going back to some stats as well, is that Here's one by year-end 2022. 1/4 of all urban infrastructure developments would be based on asset value models. Okay, so but the way we class assets now is going to change significantly in this in this new normal world of ours, you know, because Bazard's just highlighted some of the assets just in this streetscape here, and Martin's alluded to some of those assets and why they're important to help them at National Express understand and predict working patterns and maintenance regimes and predictive maintenance regimes and driver training off the back of that, you know, to enhance their service. So the bus becomes an asset of the urban landscape and of our future mobility landscape and ecosystem. So all these are now generating data that contribute to these new norms. So Bazard, do you want to move on?
Yeah, to the next case study. Adrian, you can continue with this.
Yeah. So here we've got, in the past one, we were using vehicles as the form of infrastructure, so vehicle to infrastructure as the source of data generation. Where now we're actually deploying LiDAR units, and this is a Rodeo product which we've developed with Network Rail over the past 2 years. And this is actually an infrastructure-based product where we're helping to get data from hard to reach areas that are contributing to the improved customer experience by reducing sort of delays, because 60% of delays across our rail infrastructure and rail network are infrastructure related. So 3 broad areas, you know, of intrusions, obstructions and degradation. And you can see there the types of things, you know, trespassing, cable theft is a common global problem in the rail industry. The behavioral aspects of being able to use LiDAR and AI and the pattern behavior capability that presents to say, is this person going to commit suicide? You know, and we can use these as triggers alongside CCTV information to improve the actionable intelligence that we get from there, to reduce the reliance on human intervention, but being human-centric at the same time. And then right the way down to geotechnical and the slow, perhaps, creep of that siding there. But the one that always gets me is, you know, we've got one sheep there. We like our sheep in Wales, so we don't want them on the track if we possibly can. But Network Rail have 18,000 standards across their network. Yeah, but how do you actually manage that? How do you expect someone to manage that? You know, one of the funny rules is that if there are up to 4 sheep on the line, then the train carries on regardless. 4 or more, you know, the train should actually be brought to a halt. And this is where AI, 5G, wireless mesh technology, and LiDAR really come to the fore. They operate very well in harsh environments, in low or dimly lit areas. And we're able to detect, classify, and then act upon that, you know, actionable intelligence in near real time. And that's what Martin was on about. Not just historical views of things, but predictive. So keep the network moving, maybe slow down a train, but keep the network moving, so you're not degrading the customer experience. So Rodeo is a VORTEX product, and we've developed it with Network Rail, and we're excited to be now in the early stages of rolling this out to multiple territories globally and working with multiple partners as well. So, okay, on to the next, Bazard. And here's a continuum, and you know what these 3 technologies also give you then is an ability to slowly create sort of almost like a digital twin type experience. Okay. And working with Transport for Wales. This is one of our testbed areas, or pilot areas, and first commercial deployments with Transport for Wales at Bargoed Station in South Wales. And here we're seeing the LiDAR unit over time is on the point cloud data, the richness of the data that we're getting, and that's removing the human intervention. but providing actionable intelligence and intelligent alerts to control rooms and infrastructure managers to be able to make the interventions that are needed in a timely way and based on high levels of intelligent data, which are driven by AI and machine learning.
Yeah, if I add the common factor in these case studies and the quality of data that the system provides, firstly, it's continuous data, a stream of data coming, in contrast to snapshots of data. Secondly, it's real time. The data is not stored or it's not buffered for long. It is continuously streamed in real time to the cloud for AI processing. And thirdly, it's reliable. Since there is AI element there, there is low false alarm, and there is enough specificity to the data that we provide in terms of classification and the insight that is derived from the data. And thirdly, the tunnel.
Yeah, and in the same way, so if as Bazard clicks through the animation here now, you can see how we're now creating a digital twin of this tunnel. What's happening to that cable and to that ductwork? Is there too much water in the tunnel? Is the red circle on the bottom? Is the drain filter in need of cleaning and cleansing? So let's use actionable, data-driven intelligence to create the maintenance regime, as opposed to the standard regime. We've always done it this way, so let's carry on doing it this way, and we're going to go down this tunnel whether we like it or not, you know, once a month, once every 3 months, whatever it may be, right the way down to creating a sort of a complete digital twin of that fan that's on the ceiling there as well. So the versatility when you converge these three technologies are quite astounding, and you're able to drive out those, you know, those new business models across your ecosystem. But you know, the focus is obviously in setting down the infrastructure and realizing what assets are now important and how you can generate data from them, which helps ultimately with the customer experience, making things more punctual, making things more effective.
Yes, digital twin is a popular buzzword now, and to talk about the role of digital twin in future mobility landscape, I think needs another session of its own. Digital twin comes in different use cases and in different levels. So at kind of a lower use cases, we have digitization and digitalization, simulation, emulation, and extraction of live feeded data and orchestration or prediction. But LiDAR, AI, and 5G together can help us go through this ladder of use cases for digital twin for sure.
Okay, Bazar, I think we're getting tight on time. If we've got some questions, or I think we come to a natural end, and maybe back to Luke.
Yeah, that looks good to me. Thank you very much indeed, guys. Amazing stuff. I have to say, it really looks like next generation tech for transport. So I'm really pleased we've had the opportunity to feature it today in the summit. Like you said, we have got a couple of questions. I think we've got time for just one before we wrap up. And Bezard, I'm coming to you with this, but obviously Adrian, Martin, feel free to contribute as well. Do you consider the entirety of the transport fleet across your community as part of your data gathering infrastructure? I mean, to me, having listened to the presentation, it seems like it's not necessarily vehicle to infrastructure, but almost vehicle as infrastructure. I don't know if you'd agree with that.
I totally agree. Yeah, what we're creating is to prepare for the future. Once the driverless and autonomous car are available everywhere, they all collect the same data for us. They all collect LiDAR data that they just use for their own use. But what could happen is that they could also make that data available, but for further processing and to improve the system itself, not just for their own use. And what we build here is to prepare and create that V2I, vehicle to infrastructure, network and infrastructure that we can use this data once it's available. And meanwhile, we create our own devices until such systems are available everywhere pervasively.
Yeah,
Yeah, sure.
I tie in with what Bizad on your observation, really, Luke. But I take a swing at it. Rather than these are points of data generation, data gathering, these are actually data generating assets. So Martin and National Express may view their buses very differently in 5 years' time, because they're actually generating data which has a much wider context, and that maybe adds value add into their procurement process as they retender for work, or as they evidence the value that they bring into mobility in a community and wider. So we've always taken the view as IoT, Internet of Things business, that we're actually data generators, because that's what the value is.
Yeah,
Just
absolutely.
to say, well, there's a whole history of our technologies where we've started with pilot type technology, but now they become standard on our vehicle spec. So they're actually built in things like, say basic CCTV, where it was always considered to be an add-on to the vehicle. Now it's built in at manufacturer, which obviously makes the whole deployment so much easier and becomes automatic. So the vehicle, as soon as it hits the road, is already equipped with all the technology necessary. And I can see this type of technology being factory fitted in the long term.
Absolutely. It's going to be a fascinating future for sure. Unfortunately, that is all we have time for this session. But thanks Martin, Adrian, Behzad for your contributions, and obviously to our audience for joining us. A reminder to stay tuned for the next session, which is coming up in just a few minutes, and to say that you can still contact and connect with the speakers here using the event platform at your leisure to pose any more questions. But thank you very much indeed for joining us. I will see you shortly on the next session. Thanks a lot.
Thanks, Luke.
Thank you, Luke.